So we're going to look at ionic equations, how to construct ionic equations. The first thing we need to know about is state symbols, and you should all know that S stands for solid, L for liquid, G for gas, AQ for aqueous, and we can see that those state symbols follow on in brackets from all of the formulas in an equation. The second piece of information you need to know is what are ions and how those ions are actually remembered. So we need to remember what the ions look like. And the third and the most important piece of information is this: anything which is solid, liquid or gas does not break up into its ions. So if you look in this equation here, you've got the solid AgCl, that won't break up into its ions. But anything which is aqueous or has AQ at the end will break up into its ions in the solution. Now, this is a common equation you'll use, and you'll use a silver nitrate test to test for halide ions like chloride, bromide and iodide, and they'll give you precipitates, and the colours you'll have to remember. So this is quite an important equation we can actually use and apply ionic equations to. So let's look at this then. So we've got AgNO3, which is aqueous, so that will break up into its ions of Ag+, and you can put aqueous there because they are aqueous ions, and NO3- aqueous plus NaCl. Now look, that's aqueous, so they'll break up NaCl, so Na plus the Cl-, and I'll draw the arrow there and I'll put the rest of it at the bottom. AgCl will not break up, that stays as it is because it's a solid, plus NaNO3, which you've got aqueous, that will break up, so you've got Na plus aqueous plus the NO3- aqueous. So those ions now have broken up. So what you do here is you look at any ions which are on the left hand side of the equation. There's the arrow, so this is the left hand side of the equation. If you get the same ions occurring on the right hand side of the equation, then those cancel. So in this case, what we've got an NO3 here, we've got an NO3- here, so those two will cancel. We've got an Na plus here and an Na plus here, those cancel. And those ions which cancel, we call them spectator ions, and you may have come across that word before, spectator. They're in the reaction but they don't take part, and so they cancel, and we can see that quite clearly. So now we can write our overall ionic equation as Ag plus aqueous plus the Cl- aqueous, which we've got there and there. They come together to give us AgCl, which is the solid. And that's our ionic equation, and you'll get these common ionic equations which you'll have to write in an exam. Let's look for another one. Here's another common one. This is where we use barium chloride, which is an aqueous solution. It's an aqueous solution, and that's used to test for sulfate ions. So you can see that barium will break up, barium chloride will break up. So it breaks up like this. Barium is 2+, aqueous, it's found in group 2, plus. Now this is where it becomes interesting. Cl-, chloride ions are Cl-, but you've got 2 of them there, so that's why you have to put the 2 in front there. Plus the sodium sulfate, that will break up, and you've got then Na+, this sodium breaks up, but you've got 2 of them. Okay, and that's aqueous, plus the sulfate ion SO4 2-. So you can see how really important it is that you remember those ions like sulfate. Okay, so that will help you then construct these equations. So here we go. Barium sulfate there is BaSO4. We cannot break that down. That's a solid, and it's a white solid when you test for a sulfate ion and you react that with barium chloride. It's produced a white precipitate, a white solid. Plus, then you've got the NaCl, and that breaks up. So you've got 2 Na pluses, aqueous, plus the 2 lots of Cl- aqueous. And now we do exactly the same here, and we'll now start cancelling those spectator ions. So you can see the chloride there and that chloride there cancels. You can see that sodium there and that sodium there is cancelling. And now we end up with our ionic equation of Ba2 plus aqueous plus the SO4 2 minus aqueous, and that goes on and gives us BaSO4 solid. And now that there is our ionic equation. Okay, a bit of tongue twisting there. Okay, let's have a look now at another one. And this is a common one which comes up. So it's an acid and an alkaline. Okay, again we can write ionic equations here. Anything aqueous breaks up, anything which is liquid doesn't break up. So here we go, we've got two lots of H plus ions, plus you've got the SO4 2 minus ion, and then you've got the NaOH that will break up two Na pluses, plus the two lots of OH minuses, and then that goes and gives you 2H2O, which is the liquid, it won't break up. I better put the aqueous signs here. Here we go. And the Na2SO4, that will break up to two Na pluses, plus the SO4 2 minus aqueous, because that's broken up. And now we can do exactly the same here. Spectator ions can cancel. So we've got the SO4 2 minus there, and that SO4 2 minus there, the Na plus there, and the two Na pluses there. So those cancel. So now we end up with our ionic equation, 2H plus aqueous plus the 2OH minus aqueuses, and they go on to give you 2H2Os, which is the liquid, and there's our ionic equation. So let's go for one more, and here we go. This one here, we've got calcium carbonate, which is a solid, and that calcium carbonate is reacting with sulfuric acid. Okay, and we can quite clearly see what we're forming here. We're forming calcium sulfate, carbon dioxide gas, and water. And let's see whether we can balance. Well, it's already balanced, but let's see if we can write the equation. So calcium carbonate's a solid, so that won't break up. That's CaCO3, which is the solid. Then you've got the H2SO4 aqueous, that will break up, so that's 2H pluses, plus the sulfate SO4 2 minus, and then we go this way, and we've got now calcium sulfate, that will break up, so it's Ca2 plus, aqueous, plus sulfate SO4 2 minus, aqueous, and the carbon dioxide there, so that's CO2 gas, that won't break up, H2O liquid will not break up neither. Now, let's have a look. Let's cancel any spectator ions. I can see that this one down here, the sulfate ion, will break up with the sulfate ion on that side. If you can see, on the left-hand side of the equation, the sulfate ion there, and on the right-hand side of the equation, the sulfate ion there. They're the spectator ions. And so now what we've ended up with is our ionic equation, which is CaCO3 solid plus the 2H pluses, aqueous. It's always good to put in your state symbols. Okay, then you've got Ca2 plus aqueous plus CO2 gas plus your H2O, which is liquid. So we can actually, what I'm going to do is draw a line so that you can actually see that's the equation here is at the bottom. That's your ionic equation. And an easy way to check it also is obviously counting the atoms, okay, just like balancing equations. So if you look, you've got calcium here, you've got calcium here, okay, a carbon here and a carbon here, 3 oxygens here, you've got 3 oxygens there, you've got 2 hydrogens there and 2 hydrogens there, and most importantly, charges, are they balancing? You've got 2 positive charges here, 2 H plus ions, and the calcium 2 plus on this side, so charges on both sides balance, as well as the atoms. So that is a nice ionic equation there.